Hello, welcome to session 178, Delve into the world's largest AI language model. I'm Maria, and I'm a program manager in Turing Group. I'll be your moderator today. We'll spend the last portion of the session answering your questions, so please submit them via the chat window at any point during the session. So for our main speaker today, we have Rangan Majumdar, our general manager for Bing's core search and group product manager for the Turing Group. Recently, he's been leading Microsoft AI at Scale initiative, where we pre-train large self-supervised neural networks and reuse them across multiple product groups around the company. So with that, I'll hand it off to Rangan.
Thank you very much. Thanks everyone for being here. So I'm here very excited to talk to you about AI at scale, which is how we've trained these really large pre-trained language models, and it's transforming our use of AI across the company. I'd love to tell you about it and how you can actually leverage some of this momentum yourself. This is a brief agenda of what we're going to talk about. First is just the introduction to AI at scale. What is it? Why did we do it? I'll give you a little demo of Turing NLG, which is the largest natural language generation model that's ever been announced. Then I'll talk about the AI at scale stack, which actually enabled us to basically make this kind of innovation. Then we'll talk about AI at scale in different Microsoft products. So we're actually using AI at scale in some of these really large language models today in products. And then finally, I'll talk about AI at scale for everyone, how you can leverage them yourself. So any kind of story with Microsoft and AI starts with Microsoft Research. So Bill Gates, when he created Microsoft Research in the early 90s, had this vision that computers will one day see, hear, talk, and understand human beings. And if you think about back when he started Microsoft Research in 1991, this was actually like a really bold thing to believe machines will be able to do, because the most advanced thing we had there was just like Windows 3.1. And since then, Microsoft Research has been really doing an awesome job in AI advancements, especially the last couple of years because of deep learning. So in 2016, there was this ImageNet challenge, and Microsoft Research was the first to reach human parity on object recognition. So that's the first part of being able to see. The second part is around being able to hear. So in 2017, Microsoft Research got human parity in speech recognition in one of the challenges there. A year later, we were able to get human parity on reading comprehension. This is from a Stanford test, like whether machines can actually read and answer questions about them. That same year, we actually got human parity on a machine translation task. And then we got near human parity in speech synthesis. So we were able to actually start to talk back to humans. And then finally, last year, there was this GLUE general language understanding benchmark. It's a super hard benchmark in understanding language. There's 10 different tasks. And we were able to actually reach human parity on this GLUE benchmark. So Microsoft Research has been really leading the way in all these AI advancements. A lot of these have to do with deep learning. So just being able to beat these academic benchmarks is just one part of what Microsoft is about. If you go back to our mission statement, which is empower every person and every organization on the planet to achieve more, we have to do a lot more than just research. We actually have to take these innovations and put them into products, which is a whole new set of innovations. How these large models are actually really, really hard to train. They're really hard to run in production. And also, you need all these specialized data scientists to use them. So there was a lot of questions around, like, how do we actually bring this stuff to every single person, every organization in the world? And in order to do that, we looked inside and we noticed, well, we weren't really doing AI as efficiently as we could. So the way we were organized is we had different product groups, which had their own AI teams. So Word would have an AI team working on reading and writing assistance. Bing would have an AI team working on better search. SharePoint would have an AI team working on better document management. And Outlook would have a team working on AI for better email management. So we had all these groups that were just doing AI independently. And we saw this opportunity where if we actually collaborated and shared and actually built AI on top of each other, we could be way more productive and more effective. And in order to do that, we had to bet on 3 trends that were happening in the AI industry. The first is what's called transfer learning. This is the idea that you can actually train an AI model on one set of tasks and reuse it for a different set of tasks. So humans actually do a lot of this just normally. If I learned to play the piano, I could reuse a lot of that knowledge to learn how to play the guitar. It's not like I'm learning guitar and piano completely separately. The second trend is what's called large pre-trained self-supervised networks. And the idea here is you can actually take a really large neural network, train it on massive amounts of data in a self-supervised way, and then reuse that network for your specific task. And that works way better than just training one model for that task alone. And the third thing is a cultural shift. And this is really what Satya has been pushing across the company, where we need to share a lot more, leverage others, and actually contribute to others. And he actually changed the incentive system across the company to make sure that we're doing more and more of this. And the results of these things have just been phenomenal. I'd say 3 years ago, the largest AI model we could train was about 10 million parameters. A year later, just 100 million parameters. And then earlier this year, we trained this Turing NLG model, which is a massive 17 billion parameters. So much bigger than anything that's been trained before. And you can tell from this graph that it's just really massive. So the question you might be having is, well, it's really big. What could it do? And across lots of different quality metrics, we saw this is state of the art. So I'm going to give you a quick demo of what this model can do. This is our Turing NLG demo site. And the way this model was trained is you give it a piece of text and it's trying to predict the rest of the text. So you can give it, half a sentence and it finishes the sentence for you, or you can give it a couple sentences and then it, finishes the paragraph, or it tells a story and so on. So we're going to try some open-ended things and see how it does. The first is I will start with something like today, Kevin Scott announced Microsoft's partnership with OpenAI. And then we'll hit generate and just see, what this model can says. And you can see this model actually, is very fluent. It's grammatically correct. You can see it also has some knowledge relationships, like it's starting to mention Jan LeCun, who's a deep learning expert. It talks a little bit about folks who work in OpenAI. And you'll notice that nowhere in this prompt did I talk about who works at OpenAI. And this model isn't going out to the web and, copying and pasting sentences. This is all knowledge that's actually ingrained into the model just from reading tons and tons of text. And you see it looks very much like a real news story or something like that. And just to show that it's, this is like a real demo, I can hit generate and generate something completely different. So here now it's talking about a completely different partnership. This time it's talking about build developers. So it just understands about Microsoft, Kevin Scott, OpenAI, and it just has all this sort of knowledge. All right, so just gave a demo. So in order to build something like this, we really had to rethink the entire AI stack. First, we had to upgrade Azure. So we invested in a whole bunch of AI accelerators. This includes Intel FPGAs, which we have a partnership with, and NVIDIA GPUs. So we always had the latest hardware running in Azure. The second is we had to invest in high bandwidth network, because what we found out is these really large AI models can't just fit on one GPU or even one machine, which has lots of GPUs. The machines actually have to talk to each other while training. So we needed a really fast network that uses InfiniBand, NVLink, so that these models can train super fast and these machines are talking to each other during training. Hardware is just one part of the equation. The other part is software. We had to actually go and create a lot of the software that maximizes the use of our hardware. So today we announced that we have a software called Deep Speed. We announced the second stage of it, which allows us to train models 15 times bigger and 10 times faster on the same infrastructure. And then we have honest runtime. So once you've trained this model, how do you actually get it to run in production in a low-cost way and efficiently? And honest runtime helps you do that. And then the last thing was we had to create this central AI group, which would take the best of research and actually build and put it into products and train these centralized AI models. That's those family of models are what we're calling the Turing models. And all of this is available on Azure and GitHub. So the hardware itself, it's all on Azure. The software, it's on GitHub. And very soon we're going to open source the Turing models on GitHub so that you guys can leverage the model yourself. And then with this, we've actually reorganized how we work together. So this central group, Turing, which actually builds a family of models, we can actually reuse those models across products. So that's Bing is actually using a bunch of these Turing models today. So every time you issue a query, we're using these large transformer networks. SharePoint has a lot of this integrated. Word has this integrated, and Outlook has this integrated as well. So now we're way more effective in delivering massive benefits because of the way we've changed how we work. I'll give you a quick demo of these features in action. So the first is Microsoft Bing. So now you can ask it, like one of the big things we've seen recently is people are asking more questions instead of just reading through web pages. So you can ask a question like, is a dolphin a whale? And we get this answer here that says like, a dolphin is a toothed whale. And then another question you might want to ask is, can dogs eat chocolate? And here we did this something smart, which is we don't just give you the passages that answer the question, but we actually read through all the documents here, and then we summarized the answer. So we quickly said, based on what we've seen across the web, we think the answer is no. And then you could quickly just skim through what are all the pages that actually support that answer, instead of you having to go and read through every single document and form that opinion yourself. So that's this magic this is the Turing technology back in Bing. And now let me show you how it shows up in SharePoint. This is a SharePoint site. I'm sure many of you have seen one of these before. And when you come to one of these, you're always looking for a document. You're not quite sure what's the right document, unless you're really familiar with the site. What's the right document you're looking for? So you might actually just kind of skim through and say, like, is this the document I want? You'll click on it, open it up, and say, okay, this wasn't quite right. But we've created this new feature called Inside Look, where you can actually just hover over a document. And then we summarize, once again, using these Turing language models, we're extracting what we think are the most important parts of the document. So we show at a glance, here are some sentences that basically summarize the document. So you could save time and say, yes, this is the actual document I wanted to read. When this technology is also found in Outlook. So if I go and move over to Outlook, what we want to do is actually save people time in reading and responding to emails. So if you have an email like this, where somebody's saying, hello team, here's a current set of Northwind acquisition materials, you can take your time and actually respond to it, or we've actually just generated the responses for you to save you time. And this shows up in Outlook today, but also in mobile. And you can imagine in mobile, it saves people even more time because it's a little bit harder to type there. And the last place I'll show you is Microsoft Word. So we're going to open up this water quality report. So here I'm in Microsoft Word Online. And this is a report about a fictitious company called Contoso. And one of the features we built here is Smart Find. So it works just like Find does today, where you can type in water quality. And it will automatically find all the parts of the document that mention water quality. But it's a lot smarter than just exact matching. So imagine I wanted to find what is the mission statement of this company. And notice that I spelled mission wrong. So what I would want the system to do is actually spell correct this for me. And you can see that we did that. So we said only related matches are found, not exact matches. And you can just hover over and see, look, our mission statement of this company is committed to providing the highest quality of water at the lowest possible cost. You could click on it and it zooms right to the part of the document that has it. Now, if you knew it was called mission statement, that's pretty easy. But what if you want to search for it more naturally and you don't know, like, is it mission statement or is it called goal statement? What is it called? So we can search for goal statement, and you can see the system actually just understands that goal and mission are the same thing. So it's searching semantically. And once again, you can actually click on it and it finds the part of the document that mentions here's a mission statement or goal statement. But that's not all. You can actually start to ask questions. So you can say, where does Contoso water originate from? And it says, look, I didn't find an exact match, but I think there's an answer to your question here, which says it's from the Arkansas River and the South Fork of the Colorado River. It gives you the whole passage for context just to make sure it understands. And once again, you can click and it goes straight to the part of the document. So now you don't have to just skim a document. You can just ask the questions you want yourself. Another example is how to reduce the amount of lead in water. Once again, it says, here's a way you can reduce the amount of lead in water by flushing your tap for 30 seconds, and zoom straight into the part of the document that answers your question. So this is amazing technology. All right. Yeah, and so this is what we mean by AI at scale. First, it's AI infrastructure at scale. So we're building out these massive data centers so we could train these really large models. It's about large AI models at scale. So training these really, really massive models because they have a lot more capacity, they have a lot of power. And finally, it's about deploying these models at scale. So we need to run these models for everyone. So that's today we're running them for like hundreds of millions of users, and we need to deploy them quickly and also make them scale and at low cost. And we want this to be available for everybody. So it's AI at scale for everyone. If you want to learn more, we've got these links here. So the AI at scale introduction is at aka.ms, AI at scale. We've got a deep dive. If you want to use some of the tools we have the Deep Speed library, which is found on GitHub. We have the Onyx runtime, also on GitHub. And finally, we've got this Turing NLG companion app. And then very soon, we're going to open source the Turing NLG model. NLU model, so you can actually build a lot of smart applications yourself. Thank you.
Thank you, Rangan. So now question time. So the first question from Greg is, what languages does the Microsoft Language Data Model support? Is it extensible to minority languages? Since a lot of our examples were very English based.
That is a great question. So a lot of the examples I showed you are English models, but we do have a multilingual model as well, and that is deployed in Bing today. So you can actually ask questions in other languages like Portuguese, Italian. So we're able to support up to about 100 languages, but there are some challenges also in the deep learning space. So we're like, if there's not enough data on those languages, then it's a little bit harder to train models for that. So that's what we call low resource languages. But we have a lot of researchers thinking hard about those problems. So I feel pretty good that we're going to be able to solve them.
Mm-hmm. Do you want to comment more about our, I guess, zero-shot approach, Rangan? So
sure.
To address those like low resource languages?
Yeah, absolutely. So what's really cool about this is we can actually train these models. Once we have this self-supervised multilingual model, we can actually train it on English data, and then it automatically works on all the other languages that it was self-supervised on. So you just give it training data in English, and that model can now answer questions in French, German, Italian. Same thing with some of these other examples that I showed today, like now Word. We just have to get training data for, like Smart Find for English, and then it can now automatically do Italian, Portuguese through a zero-shot approach, as Maria was saying.
Mm-hmm. Thank you, Rangan. I have another question from Christian. What is the most challenging area have you experienced in training the models in various applications? It is challenging since there are different data set for each of the scenarios and applications.
Definitely. I think that there's a lot of different challenges. One is, I'll say like the hardest challenge we've had to face is deploying these models, because we want to make sure it's at low cost. Users want a really fast experience. These models are actually very computationally heavy, which is why we work so hard in integrating all our innovations into the Onyx runtime and actually open sourcing that as well, so other people can leverage it. And then we hope that others contribute back to the Onyx runtime so that the community itself gets faster. Like I said, these are large models. They're expensive to run, but through the Onyx runtime, they get much cheaper, and then it's much easier to deploy.
Mm-hmm. I have another next question from Fred. This was after you were demoing the inside look from SharePoint OneDrive.
Mm-hmm.
After it reads information, in what form does it store that for future use? And
for inside look, I'm not sure. Maria, you were the PM, but I think it actually runs it on the fly each time. I'm not sure if it stores it.
That's right. It doesn't store. It is all live and is a pass through. So it would, when the user hovers over it, it actually goes to the full document and identifies those key sentences that represents the content of the document and surfaces it. So it's pretty impressive how fast it is able to do that.
Yeah, I think one of the reasons it needs to do that too is now a lot of people are collaborating on documents in real time, so they could change it. So you need to actually get the summary in real time, because it could change. You don't want to store it and then all of a sudden it's inaccurate.
That's right. And from a compliance perspective, we do not want to store those data. Mm-hmm. Next question from Andrew. I would like to read through the whole question. Wait, what? The English to French thing, is that some kind of transitive learning? Rangan, what do you say about that?
I think he's implying transfer learning, but yes,
yeah,
it is.
I think so. Yeah. Mm-hmm.
Yeah.
So yes, it is a transfer learning.
Yeah.
Yes.
If you want to learn more, just search for zero-shot learning, and there's a lot of content out there about it.
Mm-hmm. Next question from Frederick. What are the next benchmarks where the humans still perform better than the AI? Which are the next to beat?
Yeah. So great question. So there is the glue benchmark. There is another benchmark called super glue. And Microsoft has its own benchmarks as well. We're actually creating one called XGlue, which is really about multilingual general language understanding. So we think these AI models being able to answer questions and read and understand across lots of languages, like these multilingual models, is actually really important, going back to the first person's question. So I think there's a bunch of benchmarks there. What's interesting is there's lots of benchmarks coming out all the time, but I think also we have to be a little bit honest with ourselves that just because the model is able to get human parity, it doesn't mean the model is actually like as good as humans, because a lot of these data sets have like issues and biases and things like that. So what we're really showing is that these models are very powerful at learning patterns really well, and then it can actually automate a lot of the mundane parts for us, so that we can just focus on more of the innovative parts ourselves.
Thank you, Rangan. Next question from George. Are you getting faster results on GPU or FPGA?
Good question. So right now for training, we mostly use GPUs, but for inferencing, I would say Bing is probably the one that's using the most, or right now currently has the most AI load in real time. And we are using just a diverse set of whatever hardware we have. I'd say last time I checked, it was almost a third was using CPU, a third was using FPGA, and a third was using GPU. So each of these hardware types have different pros and cons. And you just need to figure out for yourself, like, well, given this is the scenario, which hardware works best?
Next question from Tyler. Could you please explain more about the Turing NLG integration with Bing?
Yes. So I was mentioning that Turing has a family of models. The Turing NLG model right now is not in any products today. So that's a really massive model, 17 billion parameters. It's very expensive to run. And also, we haven't really figured out like what are some really amazing customer user scenarios inside Bing. So that's not being used in Bing. What we are using is what we call the Turing NLR model. So it's called neural language representation. And what that's about is it just has a general language understanding that we can fine-tune for different things. So in Bing, we fine-tuned it for question answering and also for captions. And we've trained it in a multitask way, which means this model is trying to do solve multiple things at the same time. So it's trying to generate captions, answer questions, and also highlight parts of the passage or parts of the document all at the same time. So it was a really exciting innovation.
This will be our last question from Anirudh. Can you use this model for other NLP tasks? I guess this is kind of extending your previous answer about TNLR, I guess.
Yeah, so TNLR is pretty general. You can use it for all sorts of tasks. So you can use it for slot detection. You can use it for triggering answers. You can use it for understanding passages. So it's pretty versatile. Maybe there's a few restrictions to it, like it can only run over a certain sequence length, right? Like you can't give it, well, if you want to give it a very long document, you have to be a little bit creative how you use it. So you'd have to possibly run it across, break the document up into multiple pieces and run it that way. But I've seen like lots of companies use these types of models in creative ways. One of my favorite examples is AI2 was able to win some like a 8th grade science test or get human parity on 8th grade science by just taking one of these types of representations and just fine tuning it in clever ways, all sorts of to help answer lots of different tasks. So yeah, it's really just up to your creativity. Once you have one of these models, like what can you do? And then reuse some of the software to just make it efficient.
Thank you, Rangan. That was our last question. Do you have any final remarks?
No, I just want to end once again with, if you want to learn more, there's the AI at Scale introduction here at aka.ms/AI at Scale. There's a deep dive. There's our deep speed library, our Onyx runtime. And then, of course, there's a Turing NLG companion app. And then we will open source our model soon. So I'm looking forward to seeing what everyone does with this combination of technology and Azure.
Thank you, everyone, for joining.